Now, if you got one of the last two problems wrong, here's an explanation as to how to do it. So number 12 asked you to find the perimeter of the regular hexagon, and then 13 asked you to find the area of that same regular hexagon. So the perimeter actually helps you find the area for number 13 if you recognize that. So here we first want to look at how many sides our figure has. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 sides, which means we're going to be working with an octagon. So first, to find the perimeter, what I would do is I would draw in the central angle here. So I'm going to draw in that. Well, not the whole central angle, but just draw in that segment. Actually, yeah, I will draw on the whole central angle here. And then I'm going to find the measure of that central angle. So that central angle is going to be 360 over n, which we know that n is 8, so 360 divided by 8. And when we divide 360 by 8, we get 45 degrees. So we have 45 degrees here. Then we know that we're going to be working with this little side here of the triangle. So we can use a right triangle. And we want to find one of the angles in that triangle. So I'm going to draw that triangle again. So I'm just going to draw it here. I'm going to draw it the same way that it's in the diagram, just a little bit bigger. So I know that this side here is 9.7. Then this central angle at the top here is going to be half of 45. So that's going to be 45 over 2, or you can say 22.5 degrees. So now that I have that side, or that angle there, I can find the side that I want to help me find the perimeter. So I want to find this length here across the bottom, and I can use that by using my trigonometry. So if I use this 22.5 degree angle, so I'm going to use this 22.5 degree angle right here, or actually 45 over 2, because I like to not use mixed numbers in my calculations. Then this light blue side is going to be the opposite, and the 9.7 is again the adjacent. So we're going to use tangent. So I can say that the tangent, let's call this one x also, so that the tangent of 45 over 2 is equal to x over 9.7. So if I put this over 1 and I do my cross multiply like we did last chapter, then x is equal to 9.7 times the tangent of 45 over 2. And then I can find that on my calculator, but I actually don't even really need to find that. But I know that this right here, that's what that represents, is that x. So this is x, and then also right over here is also x. So one whole side length is actually going to be 2x. Since one whole side length is 2x, I want to use that for my perimeter. So then my perimeter would be the number of sides. So in this case, I have, we said 8 sides. So it'd be 8 times the side length, which would be 2 x's. So if I plug that in, 8 times 2 times my x is 9.7 tangent of 45 over 2. And then I go ahead and I calculate that on my calculator. So 8 times 2 times 9.7 times the tangent of 45 over 2. If it's easier to type in 22.5, go ahead. And I get my perimeter is about 64.2859. I can't remember what it said to round to. And that would be units. Okay. Then to move on to find the area. So the next question asks you to find the area, and it was the same problem. So we can use our area is equal to 1/2 of the apothem times the perimeter. So I have all my information now, so that's going to be 1/2 times the apothem is 9.7 times the perimeter we just figured out was 64.285944488. So I can take that and calculate it on my calculator. So take that answer times 9.7 times 1/2, and you end up with your area is about 311.786. That would be units squared. And I forget what that said to round to, but whatever that rounded to, choosing that correct answer. So if you didn't get this one right, here's an explanation of it. If you got it right, you can just move on. So here we have a regular hexagon. And so as I told you in the notes, that every time we have a regular hexagon, we're gonna end up with 30, 60, 90 triangles, which is why this one says you do not need a calculator, okay? So our central angle, and again, every time this will happen, so if you remember it, that's perfectly fine. So it's 360 divided by 6, so the central angle is 60. And then when I cut that angle in half to get this angle here that I just traced in blue, then this angle in here is gonna be a 30-degree angle. So now, since that's a 30-degree angle, this angle down here at the bottom has to be a 60-degree angle. So what this yellow triangle ends up being is it ends up being a 30, 60, 90 triangle. So I'm going to draw that a little bit bigger. So here's our 60, here's our 30. So we know that the opposite side is S, the hypotenuse is 2S, and the adjacent side here, this is going to be S square root of 3. So we know that 2S is equal to 20 square root of 3, as it says on the diagram. So this 20 square root of 3 is this 2S right here. So we're going to work with that, and we can say that 2S is equal to 20 square root of 3. So if I just divide by 2, then S is equal to 10 square root of 3. So that's this side right here is 10 square root of 3. Now remember, that's not the entire side of the triangle. That is only half of it. So the entire side of the triangle is this whole thing, right? So this would be like all the way across here. And these two little pieces would be congruent. So this whole side here then is going to be 2S, right? So this is going to be 2S long. And so that means that this side length, if I double that, then this would be 20 square root of 3 for the side length. So the side is equal to 20 square root of 3. And then the apothem. So the apothem here, let's see, apothem here is this length right here. And that's going to be the S square root of 3. So the apothem is equal to S times the square root of 3. So we know that S is 10 square root of 3, right? And then we have to take that and multiply that by the square root of 3. So this S right here is from here, 10 square root of 3. So we plug that in, 10 square root of 3 times the square root of 3. And that will give us then 10 times 3, because square root of 3 times square root of 3 is 3. So your apothem is 30. And so now we can find our area simply. Area is equal to 1/2 NSA. So 1/2 times, we have 6 sides. We have the side length is 20 square root of 3, and the apothem is 30. And then we go ahead and we can calculate that. I can reduce here and make this into a 3. And so then I have, let's see, 3 times 20 is 60, times 30 is going to be 1800 times the square root of 3. This would just be units squared. And there we have the area for number 15. So we'll do this next one together. If you feel like you got it, you can try it and do it on your own. But here is another explanation in case you still need it. So again, we're going to start by finding the central angle. So I'm going to draw in my central angle. There's one central angle. This is a pentagon. So my central angle will equal 360 divided by 5, which is 72 degrees. So that whole central angle is 72 degrees. And now I know that when I draw in my apothem, let's make it blue, draw in the apothem here, that apothem is going to bisect the central angle and also bisect the opposite side. So if I bisect my 72 degrees, I know this angle inside here is now 36 degrees. So if I take this little yellow triangle and I redraw it, and as you get better at this, you might not have to redraw it. I know that this angle up here is 36 degrees. And it tells me, I forgot to write this on my diagram here, it told me here that the side length was 5 feet. So this whole length here is 5 feet. So since that whole thing is 5 feet, then I can find this length here on my triangle is going to be half of that because it was bisected. So this is going to be 2.5. So I'll put 2.5. I know, crazy, I'm using a decimal. And now what I need to find is I need to find the apothem. So I'm going to call this A for my apothem. I can use trig to do this. So the tangent of 36 degrees is going to equal 2.5 divided by A. This one's a little bit harder one to solve, so cross multiply. So I get A times the tangent of 36 degrees is equal to 2.5. Then I divide both sides by the whole tangent of 36. And this will cancel here. And then I have here that my apothem is equal to 2.5 times the tangent of 36 degrees. I don't actually have to calculate that yet, but I know what that is, and now I can plug into my area formula. So area formula here, area is equal to 1/2 NSA. I like to use NSA because it's like the government, the NSA. It's easy to remember. So 1/2 times the number of sides is 5 times the side length, which is also 5 times the apothem, which is 2.5 times the tangent of 36. And then I just plug this into my calculator. So plugging this into my calculator, times 0.5 times 2.5 tangent of 36. And let's see here. I get 22.7, let's just do the nearest tenth, and that's going to be feet squared. And there we have our area. So number 20, if you didn't get this one right, here's an explanation. It says find the apothem of the regular polygon with area of 48 centimeters squared. So I can say that I have the area is equal to 48 centimeters squared, and my area formula is 1/2 apothem times the perimeter is going to equal then 48 centimeters squared. And I see I forgot to put the diagram on here, so let me get the diagram drawn really quickly. Okay, so this was the diagram that you guys had on your Kahoot. So here we have then 1/2 times the apothem, and then the perimeter is the number of sides times the side length. So the side length is 4, and we have here an octagon, so we have 8 sides, so the perimeter is going to be 8 times 4 is equal to 48. And then we're just going to solve this, so I can reduce the 1/2 with the 8 and make it into a 4. And so then I have that the apothem times 4 times 4, so times 16 is equal to 48. And then I just divide by 16, and 48 divided by 16 is going to be 3. So that means my apothem is going to be 3 centimeters.